So let's go ahead and find horizontal tangent lines. So what do we mean by horizontal tangent lines? Well, suppose you have a curve that looks maybe something like that. So horizontal tangent lines means when the slope is equal to 0. So this is a horizontal tangent. That's a horizontal tangent. So the slope m is equal to 0. So m is the symbol we often use to represent slope. So for this problem, we're looking for when will this curve have horizontal tangent line at which x values. So we need to find the slope. Well, in calculus, we know that slope is the first derivative of the function. So let's go ahead and do that. And we also want to set that equal to 0 once we have that, because that's when we have horizontal tangent lines. Well, how do you find the derivative? The derivative of a function by using the limit definition, it's the limit as h approaches 0 of f of x plus h minus f of x all over h. Now you could use the shortcut for this problem, but we're going to go with the long way if you haven't seen the shortcut yet. So I'm going to find f of x plus h using this function right here. We're going to substitute x plus h. We have the limit as h approaches 0. So the first term will be x plus h squared. Second will be 4 times x plus h minus 1. So that is the f of x plus h. And take away f of x, that is the original function, x squared plus 4x minus 1, all over h. And then we try to simplify this, that will be the derivative. So let's take the limit as h approaches 0. So from here, we're going to expand this, distribute that. That will give us x squared plus 2xh plus h squared plus 4x plus 4h minus 1. So that's from the f of x plus h. And here we're going to distribute the negative out carefully. Get negative x squared minus 4x plus 1. Everything over h. Now you should see that a lot of this stuff will cancel out. For example, x squared with negative x squared, and then 4x with negative 4x, negative 1 with positive 1. Once they cancel out, we're looking at the limit as h approaches 0, 2xh plus h squared plus 4h all over h. Since everything has h in common on top, we can factor out an h. That will give us 2x plus h plus 4 all over h. Now here, we can cancel out the h's. Then we're ready to take the limit. This is equal to the limit as h approaches 0 of 2x plus h plus 4. And now I can sub in h equals 0. That is 2x plus 0 plus 4. So our derivative of this function is simply 2x plus 4. Now we want to set the derivative equal to 0 to have horizontal tangent. So set it equal to 0. This is for horizontal tangent. So if I set it equal to 0, I will get 2x plus 4 equal to 0. So for x, you have 2x is equal to negative 4. Divide both sides by 2. X is equal to negative 2. So at x equal negative 2, this function, f of x, has a horizontal tangent. So there is only one place. Now, if you were to look at the graph of this will look something like this. So you have the function we're looking at is f of x equals, let's go back. It is x squared plus 4x minus 1. We have x squared plus 4x minus 1. So you know this is a parabola facing upward, and y-intercept is negative 1. Let's suppose it's right here. So the curve would look, roughly sketching, look something like that. Something like this. So that is f of x. So this is when you have the horizontal tangent. And when does this occur? Well, at x equals negative 2. That's when we have the horizontal tangent.